All right, so for those of you who don't know me, I'm Margie Dara. I'm a professor of mathematics at West Virginia University, and I'm part of the qualitative research team. And I'm going to talk to you today about one of the aspects of the research that we've been doing over the last few years. And I just wanted to give you an update on this area. And I think we have been able to get a set of data that is helping us in this, and I wanted to bring that to you. So just the overall idea of the rural coding from the beginning is that when we were writing the proposal, we thought about the idea of rurality in West Virginia and how many of the locations we would consider rural. But there should be a way to distinguish between the locations. We don't have very many cities in West Virginia. And so many of the ways that counties and even high schools are categorized are based on the population, or they're based on socioeconomic or distance to an urban center, something like that. Like they have the RUC codes and the NCES codes and so forth. But we wanted to create a coding that actually related to persistence in STEM and which counties are doing a better job with persistence in STEM and looking at the aspects of the counties. So we found several articles like this in the literature. People were looking at this kind of idea of taking their own state and looking at rurality and the differences in the different states based on certain ideas. Some of them were looking at medical ideas or various things like this. So let me move to the next slide. These are our research questions to begin with. Can we better classify the locales where student participants live in during their middle and high school years by identifying some resources in those areas? And then what resources do they have access to, and how has this affected their decision to attend college or pursue STEM? So one of the ways that we have been trying to get at this is to look at these different things for each county. So we have a whole list of things we've been looking at, and these are just a subset of them that we finally settled on to look at. So we looked at things like, were there libraries in that county? Were there museums, STEM museums, public transportation, post-secondary institutions in that county? How many average AP courses did they have in their high schools? What percent of the total population had graduated from high school or got a bachelor's degree or had an advanced degree? We also looked at the high school four-year graduation rate in the county, the college going rate, and then Caitlin had suggested maybe we would look at the median high school enrollments and the percent of the county high schools that were classified as rural. But the other thing that we wanted to put in this data set when we tried to classify the county was the idea of persistence in STEM. How can we relate all those other factors, which we have been looking at for a while, to persistence in STEM? So this is the new data set that we just got our hands on from WVU, and it's a 10-year data set from 2010 to 2020. We would love to have this for all colleges in the state, but unfortunately, I don't know how we would get this. But so we're using the WVU data as some kind of a proxy for this persistence in STEM, because we did have students from every county in the state in this data set. It ended up with 13,408 students in this data set. Of those, we had at the beginning, when I say it started in STEM, these were people who came in majoring in STEM from the very beginning, but then during this time frame, we also had people add STEM as a degree. So really, this is the number, this 3,264 that we looked at. During this time frame, people at WVU will know that early on, if you came in with certain ACT scores, you couldn't go right into a STEM degree. So you had to get into a pre-degree, and like pre-engineering, and you weren't necessarily considered a STEM major at that point. So I feel like this 3,000 number. So we're really looking at 3,000 students. And then we went on to look at how many of those graduated within 5 years. And that ended up being this number, 1,248. So this is something that we're using. I'll show you an example of what the data set looks like. So we summarized this for example, for Barber County. During that time frame, there were 123 students who started from that county at WVU. Then 19 of those started as a STEM major. Okay, then during that time, 17 of those continued during the first semester, went at least one semester in STEM. And then overall, 21 students from Barber County had ended up majoring in STEM, and then 9 graduated during that time frame. So you can see the numbers aren't very large for some counties, but for some counties they're a little bit bigger, like for Berkeley County, 98 and so forth. So what we are doing with this, we put these factors together with the other factors that I was showing you before, and we looked at the counties. So we had the numbers for the counties for these factors, and then we had the number for persisted in STEM and graduated in STEM, trying to look at which counties sent students to STEM. And we did this as a percentage to sort of standardize everything per county. So for example, Barber County may not have sent that many students, but we took the percentage of students. So of the overall students they sent, what percentage were STEM majors? So really, some of the smaller counties had a larger percent of STEM majors that they sent because they were sending more percentage. So we kind of tried to standardize in that way. And then we added those columns in, and then we clustered the counties. And so this is what the clustering came out to look like. This was 3 clusters. We also have looked at 4 clusters, and we'll look at 5 clusters. But I feel like this is a pretty interesting way of grouping the counties together. You can see that in cluster 1, which were the counties, these may have more resources. They certainly had more libraries, more museums. They had more higher ed institutes. This first column, almost all the numbers are higher than the second and third columns here. The idea is to look at that. Now, if you look across, you can see everything goes up except the percent of high schools that are rural. And in that, everything is higher in cluster 1, except the percent of high schools in rural. Okay, so you can see the more rural counties are in cluster 3. So approximately 91% of the high schools in cluster 3 are considered rural, coded rural in the NCES codes. You can also see that the median high school size is higher for cluster 1, then it's goes down a little bit, and then in cluster 3, the more rural counties have smaller high schools. What I find is interesting is that they actually, if you look at the percentage of STEM majors that started or added STEM, it's higher for these rural counties than it was for the less rural or the more resourced counties. But then this was the part that I wanted to focus on, is the ones that graduated in STEM. So we took the amount that had added, and I put the numbers here if you can see them. This wasn't on the original slides, but I put the number of students we're actually talking about. And of those who started or added STEM, how many actually graduated then over this time frame in 5 years. So I think we're getting at the heart of what we're trying to see is like which counties actually may be doing or may have more resources to promote more STEM persistence. And again, I think, oh, sorry, that was the next slide. That's just the counties in a color coding. But here, I feel like the last 2 rows are interesting to focus on. The cluster 3 counties sent more students into STEM percentage-wise, not number-wise, but percentage-wise, but then they graduated at a lower rate. So does that mean, I mean, I'm not sure what conclusions we can draw from this, but does it mean that, could we draw the conclusion that maybe they weren't as prepared when they got there, or they just didn't like the setting at WVU? And again, all this, I mean, the problems with the study, you know, when you write a paper, you always have to say, what are your, you know, what are the problems with your study? The problem is we're only using WVU as a representative here and not the entire state. So, you know, were the more rural students, did they end up going to another school to finish out their STEM degree? What would be great is if we had this for the whole state. Like if HEPC collected this data, and then we could really say something about the counties. So I'm sure you have lots of questions or comments, but that's basically what I wanted to talk about. And I will be presenting more on this at the conference, and also triangulating this back with our student survey for participants. Because in the student survey for participants, we asked them about what opportunities were available in their counties and what ones they took advantage of. So we can also look at, for example, let's say we have, you know, 10 students who were from these cluster 1 counties. What did they say they participated in? You know, as our participants, what did they participate in, and how is their persistence? So that's another thing that we're looking at related to persistence. So with that, I will finish and let you ask any questions. I'll leave the slides up in case you want to ask any questions, ask clarification. I'm not good at watching
about the implications of this. So I guess it's to understand more deeply the factors that are you know, barriers or facilitators to STEM persistence and graduation, so that universities or even the K through 12 system like understands them. Because I guess I'm just thinking you probably can't, it's probably not feasible to add more libraries and to do some of these things, but maybe to understand what really are the driving factors for why rural students don't do as well. So is that what you say?
Yeah, that's the idea. And because like right now we look at these, we're always looking at the high school or the county that the student comes from, and we're saying, oh, they're from rural, and do rural do as well as urban students and so forth like that. But what does it really mean to be rural when the whole state is very small? And most locations, for example, I live in Taylor County. Taylor County has Grafton. It's a tiny little town. I don't even know, you know, maybe 5,000 people, but it's not considered rural in West Virginia. So, I mean, it's not, it literally is not, the Taylor County High School is not considered to be in a rural setting. So, and it's the only high school in the county. So that's the kind of thing. You know, if we just say, do students from rural areas do better or worse than students from non-rural areas, what are we actually talking about in West Virginia? Maybe in another state it makes more sense, but Caitlin's trying to help me figure out these things. We've been talking about this, and I've asked her to look over our study since she's the expert in rural, and tell us if we're headed in the right direction, what she feels, you know, we're learning from this. And
Margie, one thing I'd add though is that I'm not sure that it's a problem that West Virginia is so rural, because
I don't think it's a problem. I've lived here all my life. I am a West Virginian. I think it's a great state. I wouldn't live anywhere else.
I'm right there with you. No, what I meant was in terms of the codes, because these are codes, these are national codes. They are used across the nation. It might be interesting to look at how this coding scheme might work in a wealthier state with lots of rurality. I think that's probably where you'd see the biggest difference, because there would be more public monies to support these kinds of resources.
Yeah, well, and that's the thing that you brought up when you looked at the slides in the first place. You said that, these counties in cluster one may be the ones that are more resourced in West Virginia. They may have the more resources, they may have more money flowing to them, and that is making the difference. I mean, we do look at things like average number of AP courses, and you can see that is something. You're right, but saying that a lot of these things cannot be changed. It's a way to describe where the student comes from, basically, and be able to say, okay, this student is coming from an area that looks like this. And then from knowing that, then you can say, well, they may need more help because they have come from an area like this. And I think that's the same way we're looking at the first gen. We're also studying the idea about first gen and the differences in first gen, because not all first gen students are made the same. Not all rural students from West Virginia are the same.
Right.
And, what do they look like? Where did they come from? What are their backgrounds? And then how can we, based on, where they're coming from, these different areas, how can we better help them?
Can you say again for me, Margie, how your clusters emerged from the data? It may be too detailed, but
no, it's not detailed at all. It's what we do. So all these things represent dimensions. So I mean, we have multiple dimensions. Instead of, if it were just 2 dimensions, we could cluster them and see the grouping on a graph. But since there's like 12 dimensions, you can't graph in 12 space. So that what it's telling us is that these counties grouped together in 12 dimensions, they are all alike in these attributes. And so that's why, we're looking at how, what the grouping tells us, that they share attributes, these counties share attributes. And I had, in that specific clustering, I said, make just 3 clusters and let's look at it. But I've also done 4 clusters and 5 clusters. And
have you seen these things? I saw AIDA had one at the ACS meeting. So there's like 12 dimensions around the outside.
Yeah. Mm-hmm.
Can you do are they similar enough that you could do something that would show a geometric difference between the 3 clusters?
Yeah, I could do that. I forget what those are called. What are those charts called? But
I've never seen one until the ACS.
I'm familiar with those charts, yeah, which also do different dimensions. I mean, I'm not sure. You could there's lots of ways to represent this. And another way that I'm trying to study it as well is through looking at how a neural network would classify these based on persistence. But the idea now that's different from what I presented before is that now we've got this representative for somehow how the counties are doing with sending students to STEM, in STEM, starting in STEM and persisting in STEM. And so to me, that's what the trying to cluster around that idea, like who's better at doing this. And it might not be the well-resourced counties. Found out that, it does tie to the resources, it seems like, if they have more of this, then they're better equipped to persist in STEM. So that's the idea.
I wonder what it would take to get you at least data from Fairmont State.
I would love that. Yeah.
It doesn't look like too hard of data, and they have been very willing to share stuff. And I bet you we have that.
Okay, I can tell you exactly what I need.
If you send me a spreadsheet with the fields you need and like how WVU got them, I will absolutely share that with Jacob Abrams.
Okay.
And Sarah, do you think your institution?
I can ask. I'd like to show this to the provost just to give him an idea of what some of this data is looking like. So yeah.
I can definitely, I would love, that's what I said. I think that's the biggest pitfall right now, is being able to say something like definitive, because we're not capturing the smaller schools. But the cool thing about the WVU data is we do have all 55 counties. And that's, at some schools, you may not have that. But if we add it together, then we'll have all the 55 counties.
Yeah, that's really, really exciting. Sorry, I just got overwhelmed in my role as steering committee runner and got lost in data geeky. Does anybody else have a comments or questions for either of these guys? There's a couple things about economic. Is there a measure of economic resource that could be added without too much trouble to the county analysis?
Yeah, I think is that what, did Caitlin ask that question? Because she was asking me that same thing. Yeah.
I think there's
Okay.
like 4 of us who put stuff in there with suggestions and
Okay.
Margie, I hang out with all kinds of data sets. I mean,
Okay.
even bad ones sometimes if I have to. So I'd be happy to like give you
Yeah.
some questions, point you in some
All right.
directions.
wow. This gives me goosebumps because it makes me really see an arc of the project that I can forget about in the day-to-day stress of just contracts and things. And I see the way that the STEM asset map, the STEM hub could intersect with this in a really great way, that we see the problem and we see things that we're doing to try to alleviate the problem at the same time. So beautiful, beautiful thing for middle of the project. Sue-Ann, anything from you?
No, I just love it when Margie updates us with
Mhm.
her good stuff.
Thank you.
It's fun and I want to dig in, and
I hope we have more for the conference. We've got all 3 areas and we're trying to relate it back to persistence. So that's the whole idea. Can we relate anything we're doing back to persistence? And we're doing the best we can.
Well, that's a pretty compelling, I mean, that difference in persistent that you're seeing right now is pretty huge.
Mhm.